of this FDP is renewable energy and e-mobility. So let us start with the fundamentals of the electric vehicle. So in this particular today's session, I'm going to discuss about the basics of EV, and the remaining part will have one MATLAB session in that how to design and how to simulate the basic electric vehicle that I'm going to represent here. So, whenever we talk about the electric vehicle, just we have to ask the question, why electric vehicle? Because now, earlier since 19th century, the gasoline or petrol and diesel automobiles are well doing in the market until today 2025, still that automobiles are unbeatable. So we have to ask a question why we are moving from conventional mobility to electric mobility. The one of we ask a question why electric vehicle, the first answer will be the petroleum resources. As we know, the most of the transportation is reliable on a liquid or gaseous fuel, that is petrol, diesel, or CNG, or that liquid nitrogen gas, or even LPG also. So these all are the fossil fuels, and basically this particular process of formation of fossil fuel requires millions of years of process because it can be generated through the decomposition of organic matter which is trapped into the earth pocket, and the process requires high pressure and temperature to decompose it and to get it converted into the fossil fuel. But however, as I mentioned that this particular process requires millions of years, so one can't bury the organic matter into the Earth's pocket and can have a fossil fuel after 10 years, 20 years. So as this process requires millions of years, and the pressure and temperature is also one of the major concern when we talk about the fossil fuel. So these petroleum resources are keep on reducing the stocks. As this particular second screen will see that the region-wise petroleum reserves are mentioned, like North America, South and Central America, Europe, Africa, Middle East, former USSR, means currently Russia, Ukraine, and this region, and Asia Pacific. So you may see that crude reserve in 2000, year 2000 in billion tons. Likewise, North America will have 8.5 billions of tons, and so on. Here you can see that Middle East is the largest contributor of crude oil production, that is 19.2 billions of tons. And at the end of this particular table, you may see R by P ratio. So what is that R by P ratio? Basically, R by P ratio is the number of years that crude reserve would last if the production were continue at its current level. Current level means this particular survey has been done in year 2000. Production is mainly depending upon its utilization. So the number of vehicles and the number of automobiles available in year 2000 and the total reserves, we just take a ratio, then we'll get R by P ratio. It's simply a year. How many years we can utilize that particular fossil fuel? So total world have crude reserve in 2000 is 142.1 billions of ton, and if the production level is at current level, that is in year 2000, then it will last up to 39.9 years. That means from 2000 we can say that up to next 2040 the petroleum resources will be available. But however, we need to think about the current consumption of the petroleum. Basically, when we talk about the year 2000 and year 2025, the consumption is almost twice, almost doubled as the number of automobiles are increased. So the consumption is also increased. So we can say that the 2040 deadline will not be there and it may last up to 2030 or 2035. Even though if we discover new resources for the fossil fuel, it is quite difficult to extract from the earth, because if we say that if the crude oil is available at the base of the Mount Everest, then think about the technology or the amount or the investment required to extract the fuel. As today is the petrol price in India is around 104 and diesel price is around 94, 95 rupees. So we can say that if the extraction cost is more, then the cost of fuel may be a 500 rupees per liter. So it's quite difficult. Again, I will give one more example. If the crude oil or gaseous pockets are available at the bottom of ocean or any Pacific Ocean, especially. So it is quite difficult to extract these kind of fossil fuel, and even though if we extract that, the cost of extraction would be more. So again, there is the ringing bell to us that whether how many years still we can survive with the existing fossil fuels. In 2021, Britain have clearly announced that by 2030 we will be the full electric transportation media. So they started to convert because the European countries are mainly reliable on the Russia and the Middle East for their fossil fuel requirement. And of course, the India is also one of the part of that, as we have very limited availability of fossil fuel. As like near to Bombay, Bombay High is the name from which we can extract the fossil fuel, but still it is unable to fulfill the demand of our country. So each country has to think that whether we will wait until the exhaust of entire the crude oil reserve, or we should shift to the some other media. So during research, it is found that the electric mobility is one of the cleanest and what you can say the which doesn't require any kind of fossil fuel for its operation, is the one of the electric mobility can be a good transportation media of the future. So this is the one of the reason why we are moving towards electric vehicle. Another reason is three reasons basically you might have seen on your screen. That is, first is air pollution, of course. By burning of fossil fuel uh, or the combustion of hydrocarbons produces carbon dioxide, and basically it is named as the greenhouse. And apart from the CO2, some nitrogen oxides, carbon monoxides, and unburned hydrocarbons are freely released into air, and these are hazardous to the human as well as animals. And what happens exactly? It will cause the CO2 is basically causing the global warming, as it is named as a greenhouse gas. Basically, what happens? We have our environment. The Earth have its own environment, and in the image you can see that left side natural greenhouse effect and the human greenhouse effect. Two images are there. In that one is the naturally available CO2. In that sunlight can enter into the Earth's surface, and usually light have either reflection or refraction as per the its own principle, and it will majority of earth body is of water, so it will act like a glass surface and the light get reflected back to the space. But however, due to the human contribution in greenhouse, the dense greenhouse layer is formed in the earth surface. What happens when sunlight enters to the earth surface, it will strike to the some body or some water body, it get reflected back, and while getting reflected back, the entire heat will not transfer to the space. These gases are getting heated up, and the heated gases cause the increasing temperature of the earth, and typically it is called as a global warming effect. And we know that there are severe impacts of global warming effects. Basically, it is interlinked with the induced cost, the third point, the third answer of why we are moving towards electric transportation. Suppose I take an example that we are burning the fuel into the cars or vehicles, and it emits the several gases like CO2, NOx, carbon monoxide, or hydrocarbons. Basically, these gases are inhaled by human beings, and usually it get trapped in our lungs, and basically the lungs undergone through some diseases like asthma, for an example. So, for asthma, that particular person has to visit to the hospital, he has to meet to the doctor, and for the treatment, he has to bear some cost, and that particular cost is nothing but a induced cost. He has paid for his particular disease, but it happened because of combustion of fossil fuel. So it is called as the induced cost. One more example, if we cut the forest and there is a more emission of CO2, usually due to the acidic gases, the acid rain happens. And suppose if acid rain happen on one of the jungle or any of the area which have good fertility, usually due to that acid, that crop or that plants are get damaged or they get died. So if you want to restore it, then you have to replant it, and replantation requires some cost, and this particular cost is called as the induced cost. Third is the cost spent on damage control due to the flood and hurricane. Because of this global warming, suddenly in certain area the excessive raining will happen and it will cause some floods. or due to the turbulence in the air, it may cause the hurricanes. So in any of the case, it will damage the properties or life of the human beings. And to restore both, we require to pay some cost. However, the damage or the cost involved in the recovery of flood or hurricane is still uncountable, because certain amount is paid through the government and certain amount is paid by the particular person who is affected by flood or hurricane. So these three comes under the category of induced cost. Why it happens? Because of combustion of fossil fuel, and indirectly the cost has to be paid by human beings, and this particular phenomenon is called as a induced cost. So almost four answers we have why electric vehicle. One is availability of fossil fuel, second is air pollution, third is global warming, and the fourth one is induced cost. So let us talk about the history of electric vehicles. History is quite, we can have some idea about when electric vehicles are started. Majority of time after 2000, year 2000, we used to talk about the uh, electric vehicle, but the journey has been started in 1834. The Thomas Davenport was the one of the scientists who built the first battery operated EV, and which is run on the non-rechargeable batteries. Basically, the unless and until we have innovation of lead acid or the storage type batteries, the earlier EVs were operated on a non-rechargeable batteries, as like that of we are using a small cell in our watch that just need to be replaced after we exhaust the energy. Further, in 1881, Gustave Troche, he is a French scientist who developed first electric tricycle, which have some major contributions like zero point 0.1 HP DC motor and lead acid battery, which is basically rechargeable type. So this is era of after we invented, human beings invented lead acid batteries. Further, in 1883, the British professors built a similar EV, but however, certain modifications and the certain upgradations has been done in this particular model, which have 15 km per hour speed, and the full charge in one charge it can travel up to 16 kilometers. These are still till 1883. These are the prototypes or just an experiment. But the first commercial EV is launched as a. Its name was the Electrobot, and it is by the Morris and Salams. It has the speed of 32 kilometers per hour, and its range is 40 kilometer per charge. And further, parallelly, the gasoline or petrol or diesel automobiles have taken advantage of recharging time of battery, and the gasoline or petrol diesel automobiles become started to popular at the early or sorry late 80s or early 90s, and so that the EVs have slowly started vanish by 1930. So in the image you can see one timeline and how EV started and how it further progressed. Around 1980, 1992, some research was started on hybrid electric vehicles. It is because in 1977, uh, 73, interest in EV rises due to the oil crisis. Because of some issues at international level, the Gulf countries have stopped to uh, release or to sell the crude oil, and so that immediately world can understand that if this is the scenario and one day they can stop to sell the crude oil, the immediate effect will be on the transportation. So many researchers again came back to the or again they started to talk about the electric vehicles and hybrid vehicles. So this is about the quick history of electric vehicles. This is generalized architecture and component required in EV. Basically, we can say that just it's an automobile, basic automobile. Conventional vehicle have some engine, petrol tank, some controls, and other things. These are getting replaced by batteries, that is energy source. To control the power flow, we require power converters, and the engine is replaced with the electric motor, and the controller is required to control the speed and torque of the vehicle. Remaining automobile is still as it is. It have vehicle shell, body, tires, steering mechanism, everything remains same. Just the that particular drivetrain, engine or mechanical drivetrain is replaced with the electric drivetrain. That is the major difference. So we'll talk about one by one. This is the functional block diagram of electric vehicle. Left side, you can see that the brake and accelerator commands that is under control of driver. And the EV is divided into three subsystems. One is electric propulsion system, which consists of major components of the EV. The second subsystem is energy source subsystem, which have some battery management systems. And the third system is the auxiliary subsystem, which consists of the air conditioning unit or climate control unit, indicators, lights or lightning systems of the vehicle, horn system, music system of the vehicle. This comes under the auxiliary subsystem. There is one more input you can see that steering wheel. So from diagram you can understand the double lines can be treated as a mechanical link where it is just at after the electric motor and mechanical transmission is the mechanical links. The solid arrow is representing the electric link, electric power flow link, and the last the thin arrow represents the control links. So brake, accelerator, and steering are the control links, and the solid rings are representing the electric rings, and double connections represent the mechanical links. So when we talk about the first subsystem, electric propulsion subsystem, it consists of a vehicle controller. Vehicle controller is the primary or the top level controller which receives all the commands from the driver. That is braking, acceleration or steering. So that command is received by the vehicle controller. The vehicle controller have one control link is connected with the energy management subsystem or energy source subsystem, and the direct link is the control link. One more control link is bidirectional control link is connected with the electronic power control converters. Further, that power converter have bidirectional electric link with the energy source as well as with the electric motor. And the electric motor is the major output of mechanical output of vehicle. So it is directly coupled mechanically to the mechanical transmission, and the mechanical transmission is connected with the wheel. Here you can treat that mechanical transmission is a coupler or a gearbox, which transmit mechanical power from electric motor to the wheel. So this is first subsystem, which is electric propulsion subsystem. The second system is energy source subsystem. In energy source subsystem, there is one energy source. Energy source is most popular energy source will be the battery, and some advanced power sources, energy sources are discovered, which is ultra high speed flywheel and ultra capacitors, or sometimes it is termed as a super capacitor. And one energy refueling unit is there. Basically, it's a charger, and there is one energy management unit which manage or which give bidirectional control links to the vehicle propulsion subsystem as well as internal energy source and energy refueling unit. Because energy refueling means and the energy source means basically battery have its own state of charge, 20% charge, 30% charge, 50, 80, 60, whatever may be the charge is available with that battery or energy source that need to be assessed by the energy management unit, and based upon when the energy refilling unit is connected, means charger is connected, the energy management unit will activate and it will ensure that the battery will charge up to its optimum level or its maximum level. And the energy management unit is again interlinked with the vehicle controller. Vehicle controller first ask energy management unit whether after receiving the accelerator command or acceleration command, it will check with the energy management unit whether energy is available or not. If it is not available, even though accelerator is pressed, the vehicle will not move. So it need to be checked every time whether the energy is available in energy source or not. And based upon that, it will have some additional battery management system also, or cell balancing system also, which ensure that the battery cells will get evenly charged so that there will be avoiding of overheating or overcharging of the power cells. The third subsystem is auxiliary subsystem, in which again the same energy source, same battery is going to supply the auxiliary units like air conditioning unit, lightning units, headlight, indicators, horn, etc. The music system of the vehicle, and the same system is going to power the steering wheel, because nowadays the power steering is implemented which consists of electric motor for its operation. So this is the functional block diagram of a vehicle. Let us talk about the motors. In early era, the DC motors were implemented, and the as the majority of people belongs to the electrical engineering fraternity. So DC motor are the brushed motor, and these are quite uh, mechanically unstable, or quite, we can say that it requires little maintenance as compared to that of induction motor. And the DC motors are quite noisy also as compared to the induction motor. So these two motors are just early inventions, and in earlier models, as I am talking about 1834 EV has been started in that era, DC motors are only available, and these kind of motors are used. And later on, the after the invention of AC electric supply and AC induction machines or AC motors, later on the DC motors are simply replaced by the induction machines, as these are relatively cheap, and these are the self-starting, and it requires little maintenance as compared to the DC motors. Further, the invention in motors lead to the design of brushless DC motor or BLDC motor, well known to all of us. And basically, the BLDC motors have two types: the inner runner type and outer runner type. The inner runner type motor looks like an ordinary motor which have shaft at the central core, and the outer runner type motor is having rotor at outside. And these kind of motors are used in electric two-wheelers, or basically the, as like I will give an example of Ola Electric or Bajaj Chetak, where the rear wheel of the vehicle itself a motor, and on the outer surface of the motor there is a tire. So these kind of motors are used in two-wheelers, and the central shaft core motors are used in the four-wheeler applications. And then further, there is the development. There is a one new candidate have entered into the field of electrical machine, that is called as a switched reluctance motor. The major difference between BLDC, brushless DC, and SRM motor is the BLDC motor consists of permanent magnets on rotor, and this requirement is get eliminated in case of SRM motor. SRM, switched reluctance motor, is having a piece of iron kept in a magnetic field, and it's similar to that of moving iron instruments. It work on a similar principle to that of moving iron instrument. So, but while controlling these two motors, we required some Hall effect sensors. In order to know the rotor and stator teeth alignment, we required Hall effect sensors, and based upon the Hall effect sensor input, the power supplies get designed, and it will have a switch. It operated in switch-like manner. So, if there are three phases R, Y, B, or sometimes it is also called as A, B, C, the switching pattern or switching sequence can be decided. So whether the rotation is in forward or rotation is in backward, accordingly either sequence will be A, B, C or A, C, B. Likewise, forward and reverse operation can be managed. Further, there is a PMSM, permanent magnet synchronous motors are widely used in the EV application nowadays because its torque capability and controllability. The PMSM motors are more popular in case of electric vehicle application. Tesla typically have designed their own motor, PMSM motor, and which have around a speed of 16,000 RPM. You may think about, we usually test motor in the laboratory, or we use the motor in the household applications of maximum 1500 RPM to the 3000 RPM, but the motor installed in the Tesla is of 16,000 RPM. Basically, why 16,000? It eliminates the need of gearbox. So, yeah, in order to increase the vehicle speed, in case of ordinary automobile, petrol or diesel automobile, we used to shift the gear first to first, second, third, fourth, fifth, sixth, like as like. In that, it is basically speed and torque converter, and engine have its own limitations. So it operate basically around 6,000 RPM maximumly, but engine is unstable device, so it is advised to use it on a 2,000 to 2,500 RPM maximumly. Otherwise, due to the vibration, it becomes unstable. But in case of electric machines, we can operate at any speed range, and these are motors are quite and the smoother in operation and easy to control. So motor can be operated at higher RPM. And this particular eliminates the need of gearbox in case of electric vehicle if we increase the speed to the 18,000 or 20,000 RPM. Even Tata and Mahindra is also using same permanent magnet synchronous motor, and all the two-wheeler manufacturers are using the BLDC motor at present. Storage devices used in EV, basically it begins with the non-rechargeable batteries, but as the lead acid batteries were invented, lead acid batteries are widely preferred in early era in the field of EV or for the operation of EV. Basically, it requires lead acid solution, lead electrodes PB and PbO2, positive and negative electrode. It is immersed in the H2SO4 solution, and due to the reaction, the Pb and SO4 gets formed. That is, PbO2 get reacted with the SO4, and H2 get released, hydrogen get released, and so that electric current gets flow. But however, there is the issue with these batteries is there is a formation of hydrogen. As we know that hydrogen is quite explosive gas, and it can harm the battery as well as vehicle if it get exploded. So later on, dry type batteries were preferred, nickel-based batteries, but these batteries widely used in small applications, and these particular batteries consist of nickel. Uh, nic Nickel, and these are hazardous, and nickel cadmium, basically cadmium is the hazardous, and the nickel ion, nickel cadmium, nickel metal hydride systems were implemented, but still they have their own drawbacks, and nowadays all the manufacturers of the EV are preferring the lithium batteries, in that lithium ion and lithium polymer. Recently I hear a news about that Tesla is implementing the sodium batteries. So the lithium will get slowly replaced with the sodium batteries. Still, there are certain research is going on in aluminum air batteries, where aluminum air core is used, and these are lightweight batteries. And if we get the lightweight batteries, the automatically the weight of vehicle get reduced. So the majority of research in nowadays is going on the new technologies on the batteries. So this is one of the research area, prominent research area. Day by day, battery need to be replaced, because still there are certain disadvantages of lithium batteries. Because if the batteries are exhausted, then it need to be replaced, and the replaced battery or the old battery need to be exposed into the environment, and it is hazardous to environment. So that's why Tesla initiated for the sodium batteries. So this is about the battery technologies were used in the EV, and the modern devices like fuel cells. Fuel cell, as we know, there is a requirement of hydrogen for the and oxygen, and there will be a reaction, and water will get released to the reaction, and the electrons will flow, and the electric current get produced. But however, still there is issue with the hydrogen storage in these particular vehicles, or particularly fuel cell. There is one pilot project is launched by Toyota. It is named as a Toyota Prius, I guess. So this Toyota pilot project is consist of fuel cell in their vehicle. So the battery is simply replaced with the fuel cell. It is much superior as compared to the battery, because unless we have issue with the hydrogen storage, if we overcome that particular issue, we no need to stay for 1 hour for getting recharge of battery. Simply we are as like filling of CNG or LPG gas, we can fill the hydrogen, and we can continue the vehicle journey. As the EV have major concern of stopping time or the recharging time of 1 hour, so it affects the journey time also. Further, there is new implementation in capacitor technology is named as ultra capacitor. Basically, the battery is the high energy density but low power density device. Ordinary capacity is high power density but low energy density device. So, the best two qualities of battery and ordinary capacities are get combined, and there is a new invention is called as a ultra capacitor. So ultra capacitors are basically high energy density and high power density devices which can be used in a EV. But however, the cost of these two devices is somewhat at higher side as compared to that of battery. So again, there is need to have a research in this particular fuel cell technology as well as ultra capacitor technologies. Power converters used in EV. As I said or I discussed about the three main sources of electrical energy, that is battery, supercapacitor, and fuel cells. There is of course a requirement of power converter which modulate or to control the power. So best primary is DC to DC converter if there is a and basically type of converter is depending upon the electrical machine or the motor used in the vehicle. So DC to DC converter basically used where the motor is DC and the basically battery, super capacitor and fuel cell. All three are the DC devices. In that case, DC to DC converters are suitable. DC to AC converter is used when the particular machine is of AC type like permanent magnet synchronous motor or BLDC motor even. DC to DC bidirectional and DC to AC bidirectional. So again, it is DC to DC bidirectional if motor is DC, DC to AC bidirectional again motor is AC. However, bidirectional is required because there is a concept of regenerative braking where the electrical motor acts as a generator during the braking operation and it produces some electrical energy and that electrical energy get transmitted back to the storage device, either to the battery or to the super capacitor back because fuel cell does not have facility to recharge. It just required hydrogen to produce the electric energy. Meanwhile, supercapacitor and battery have ability to charge and recharge. So during regenerative braking, the supercapacitor and battery can get charged. The semiconductors used in a power converters is of thyristor type, MOSFET type, or IGBT type. Nowadays, IGBT is quite more popular to design or to manufacture the power converters for the EV. Most important, battery management system or BMS system. It is integrated part of the energy source subsystem because as we know the battery have several number of cells. Take an example of 100 cells per battery and each cell is not at the same state of charge because as I said that the battery is a high energy density but low power density during certain conditions like frequent acceleration or deceleration commands the suddenly battery feels jerk and certain cells get over discharged and certain cells remains as it is. So it may possible that out of 100 cells, 20 cells are almost at zero charge, 20, 30 cells at 20% or 30% charge. Some are at 40, 50, 80% charge or remaining at 100% charge. So in order to balance all these cells, means in both case, while delivering the power and while recharging the power, there is a need of battery management system. It selects while recharging the lowest SOC cells and it will continue to follow the sequence from lower to the higher SOC cells. During discharge also, it will take first power from higher energy cells and it will continue towards the low energy cells. So this particular system have battery state monitoring or battery state determination because knowing the state of charge and it can be done through the current voltage and temperature. Temperature is also one of the important concern. If the battery management system fails, it will give rise to the temperature of individual cell and as we have listened several news that EV catches fire. It is because of failure of battery management system the cell get overheated and it catches the fire. The acceptable temperature is 35 degree and if the temperature is reaching beyond 35 degree and it will automatically catch the fire and entire EV may getting the fire. So the integral part of it is the integral part of vehicle battery management system. Further, energy management system. Energy means what? If we are using multiple sources like ultra capacitor, battery, and fuel cells, these all three have different characteristics because fuel cell is only unidirectional device. It does not store the energy. It requires hydrogen for the its energy conversion process. Battery is a high energy density but low power density device, and it can be used for charging and discharging both purpose. Ultra capacitor is having high energy density and high power density. So again, battery and ultra capacitor have capability to charge and discharge energy. So energy management system has to play an important role from which source power can be taken for the driving. So for an example, fuel cell is used in a vehicle. I have shown here all three sources, but it is quite difficult to incorporate all these sources into the vehicle. A combination of two is much suitable and economical and easy to control when we talk about the energy sources in an electric vehicle. So suppose the battery and fuel cell is used as a combination, and the for acceleration the power is given through the fuel cell. But however, during regenerative braking, it is quite difficult to store, or it is not possible to store the regenerated energy into the fuel cell. So that is get diverted towards the battery. And the switch, you may see that each fuel cell, battery, and ultra capacitor, all three are connected with the individual converter. And further, there is one switch. Switch will have just an operation on and off. So according to the operation, acceleration or braking, the switches are getting operated. Regenerative braking. So basically, when we talk about the regenerative braking, when there is a driving energy is required, a vehicle is supposed to move forward. The power is flowing from the battery or any energy source to the motor through the converter, and it is controlled by the controller. But when it comes to the braking operation, because of vehicle inertia, axle of the vehicle or the wheel of vehicle are continue to in the motion, and the supply from battery to motors get cut off. Under such situation, motor still receive mechanical power from the transmission and wheel. And under such case, that same motor get act as a generator, and load is applied directly to the wheel, and the amount of electrical energy gets stored into the battery or supercapacitor. That's why here we required bidirectional energy converters, and this is how regenerative braking system operates. So this is up to my presentation, and I will now talk about the simulation. Is it visible? Simulation is visible.
Yes, sir.
Okay. So as I mentioned that there are several subsystems are required for the operation of EV. Right now, simulation is under working because it requires longer time, and purposefully I have kept in a running situation so that I can show you the output results. So here there is one system driver input. I hope you could able to see the driver input. I will open the block one by one so that you can understand the things. Yeah, here you can see that a driver, a longitudinal driver. The scope in given in a MATLAB that we can have a driver so that based upon the input command, it can generate the brake and acceleration command. I will just open the longitudinal driver block. Yeah, you can see that. Right now simulation is under working, so I can't change the parameters. But control type, you can see that here predictive controller I selected. You can select PI also. Based upon the gain values, you can set the PID gains, and the vehicle will, that driver will generate the output commands accordingly. So the input to the driver block is V reference, that is velocity reference. Feedback from the vehicle output. Grade means if the vehicle is supposed to operate on a grade. Grade means on a particular slope, 10 degree, 20 degree, 5 degree, like that. And the output of the driver is acceleration command and deceleration command. The V reference, the velocity reference can be given through the drive cycle source. The drive cycle is the basically it's a speed time curve. Right now it is unable to open. Yeah, simulation is under working, but it's basically a speed time curve where the rapid speed and time speed commands are generated with respect to time. So here there are several sources are there, drive cycle source. In that there are different drive cycles are incorporated, I have selected here FTP75. This particular drive cycle runs for 2474 seconds. And you can, after simulating, you will have a different parameters for the system. And you can have some manual commands also. You can have your own manual signals also for speed. There is one block signal builder is there, and a signal builder through signal builder, you can keep or you can design your own speed and time commands. But however, it is a signal builder I have opened, and it is just a single command up to 4 seconds. The vehicle will be at zero speed, then further at 4 seconds it will rise the speed. 4 to 6 seconds it will continue at the same speed, and after 6 seconds the speed will rise falls. So accordingly you may have your own commands or to control the vehicles. It is basically a speed time curve. Based upon the input received from the drive cycle source, the longitudinal driver will continue to generate the acceleration and brake commands. So this is the primary subsystem is available in a MATLAB. Just you need to search the respective blocks and you have to connect the uh, connections. Then there is one another block, motor and controller block. Here, input 0 and input 1, this particular side is received from the acceleration and brake command. Input 0 is acceleration command, input 1 is a brake command. These are connected to the basically controlled voltage source, and the controlled voltage source are connected to the PWM, control PWM generators. So based upon as these particular commands, input 0 and input 1, that is acceleration and brake commands are physical commands that need to be converted into electrical signals so that further the converter, H-bridge converter, you can see, it won't understand the acceleration and brake command. It simply understands the PWM commands or the voltage commands as the input. Here we need to connect all the input commands, that is PWM command, reference command, break command, and revolution command. And the output of H-bridge converter is given to the DC motor. Here you can see DC motor. I'll try to zoom. Here you can use any type of motor. For the simplicity, I have connected the DC motor, and further the this particular measurement only, that is current sensor, and through current sensor the one output is taken, and further this particular motor is connected with the this is combination block is directly available, motor and its output shaft command, and I have taken these outputs. Further, after motor controller block, there is one battery block through which receive the signal. The input one is from the current sensor. This particular one is from current sensor, input one, and the input is connected to the controlled current source, and the controlled current source is connected to the battery. I have used multiple batteries here to just ensure or have a different category of parameters can be generated. So battery output is state of charge, current, and voltage. That is again taken out, and it is connected to the scope. And one more important block here, you can see that vehicle body and tires. I will open the block. Yeah, this particular B signal is simple here, BF, and the input to the B is given from the motor output. Our motor shaft is connected to the gear. Here it's a differential for the axle. Here there are two tires, that is the rear tires I have just taken. Front tires also can be connected. Uh, Tire with magic formula. Here you can see it, the parameter, that is vehicle vertical load 3000, peak 3500, geometry, rolling resistance, if you have parameters from any vehicle available in the market, like Tata Nexon or Mahindra vehicles, or even though Tesla also, you can have input parameters for these three: two tires, one acceleration axle, and here it's a vehicle body and steering commands. I will open the vehicle body. Here you can see the settings for the same mass. You can set at any kg. That's why I tell that if you have, if you know the parameters from the market vehicle, you can easily set it. A number of wheel per axle, usually wheel per axles are two, and sometimes in all-wheel drive there will be a four. Horizontal distance from center of gravity to front axle, center of gravity to rear axle, center of gravity height, everything we can set here. Even we can set aerodynamic drag, drag coefficient, frontal area of the vehicle. Even you can simulate a truck also, you can simulate a bus also. Just you need to have some parameters and which can be incorporated into that particular settings. So these four subsystems are required to design a vehicle in a MATLAB. As the simulation in running condition, I can show here. This is SOC 80.71. I'll show the graph. This is SOC graph. You may see that SOC is rising, again falling, rising, falling, rising and falling. So wherever SOC is falling, it is basically a brake command where, sorry, acceleration command. The power is given from the battery to the motor. That's why the state of charge is getting falling. Wherever it is rising, it's a braking command because it acts as a, generator and the battery get recharged. So at this particular location, it is rising. You can set battery parameters also, what kilowatt hour battery is required, and you may see this is the speed command. The speed command and speed graph and or velocity graph and battery graph is exactly reverse. So wherever speed rising, battery SOC will fall. Wherever speed is reducing, the battery SOC will rise. So here you can see that the how vehicle velocity is changing. The blue line, you can see that how it is changing. Basically, till now, the simulation is run for around 120 seconds. So we have to wait for total 2474 seconds. Likewise, other parameters also can be monitored. Current, voltage. You may see that current is keep on changing here because the acceleration command requires higher the current. And sometimes you may see that current is going to the negative value. It is because of regenerative braking. The current value is represented by minus. Voltage is there. Wherever voltage is falling, that means the acceleration command, and wherever voltage is rising, then it's a regenerative braking command. You can see that the distance is traveled by the vehicle. Yeah, you can see that distance traveled by the, it is keep on rising, but it is slow. Velocity, you may see that velocity is also keep on changing. Distance is integrator. I have added one integrator so that it will count. You may see the current graph also. Yeah, this is current graph and this is voltage graph. So if you have basically it is quite easy to design vehicle in MATLAB because